Hello students, in the last lecture we completed with the study of metals, and in this lecture we will know about non-metals. So let us start with the study of non-metals. Non-metals. Students, though non-metals are less in number as compared to metals, but these are very essential in our daily life. As we have oxygen, which is very essential for respiration, carbon, nitrogen, etc. So these elements are included in the category of non-metals. First of all, let us know how to define non-metals. Based on their physical properties, non-metals are defined as the elements which do not possess luster, neither are good conductors of heat and electricity, nor are malleable and ductile. So let us know how to define non-metals. Non-metals are defined. Non-metals are defined as elements which do not possess luster, neither are good conductors of heat and electricity, nor are malleable and ductile. So students, non-metals are just opposite to the metals, as metals are good conductors of heat and electricity, but non-metals are not good conductors of heat and electricity. Metals possess luster, they do not possess luster. They are malleable and ductile, but these are actually brittle. They are not malleable nor they are ductile. So this is the definition of non-metals, seeing their physical properties. But we look at the structure of the atom of the non-metals, then we say non-metals are the elements whose atoms can easily gain the electrons to form negatively charged ions. So next definition of non-metal says, or non-metals are elements which gain electrons easily and form negatively charged ions. Negatively charged ions. And students, negatively charged ions are known as anions. As positively charged ions are known as cations, negatively charged ions are known as anions. So these negatively charged ions are known as anions. And as they form negatively charged ions, these elements are also known as electronegative elements. So non-metals are also known as electronegative elements. I hope these two definitions of non-metals are clear to you. First definition is by seeing their physical properties. They do not possess luster. Neither they are good conductors of heat and electricity, and nor they are malleable and ductile. As these properties are possessed by the metals, these are non-metals, they are opposite to metals, so they do not possess such properties. And seeing the structure of their atom, we can say non-metals are the elements which gain electrons easily. As metals can easily lose the electrons, but opposite to the metals, non-metals can easily gain the electrons to form negatively charged ions known as anions, and therefore they are also known as electronegative elements. Now what about the occurrence of the nonmetals? As metals are present in the earth crust, so are non-metals also. So first of all, they are present in the earth crust. The most abundant element present in the earth crust is oxygen, and that is a non-metal. So the most abundant non-metal present in the earth crust is oxygen. So first of all, we have oxygen, and it is the most abundant element. Where it is most abundant? It is most abundant in the earth crust. Most abundant in earth crust. And what is the percentage of oxygen in the earth crust? The percentage of oxygen in the earth crust is around 50%. So it is the most abundant element, and as it is a non-metal, so we can say the most abundant non-metal in the earth crust is oxygen. Second most abundant non-metal in the earth crust is silicon. This is the second most abundant element. Second most abundant non-metal in the earth crust is silicon. And talking about the percentage of silicon in the earth crust, it is around 26%. Now this was about the occurrence of the non-metals in the earth crust. They are not only present in the earth crust, even they are present in the air and the ocean. So second, air and ocean. We know that the most abundant element in the atmosphere is nitrogen, and nitrogen is a non-metal. So they are present in the air, as we have nitrogen, which is present in air. It is the most abundant element in the air. Now in the oceans also, student, oceans, in this hydrogen and oxygen in the form of water is present in the oceans, and both hydrogen and oxygen are non-metals. So we can say we have hydrogen and oxygen. They are present in the form of water in the ocean. So this was about the major occurrence of the non-metals. Next, let us study what are the physical properties of the non-metals. How we can differentiate the non-metals from the metals on the basis of their physical properties. So for that, we must know about the physical properties of non-metals. Physical properties. When we have to discuss the physical properties of any elements, first of all, we studied about their physical state, in which state they are present at the room temperature. So first, students, is about their physical state. Different from the metals, as metals are mostly present in the solid state, we have one metal which is present in the liquid state, and the metal is mercury. But different from the metals, these non-metals are present in three physical states. So three physical states are solid state, they are even present in the liquid state, and many of the non-metals are in the gaseous state. So they are present in three physical states at the room temperature. We have to study the examples of the non-metals in the solid state. Then the examples will be like sulfur, carbon, phosphorus, etc. And there is only one non-metal which is present in the liquid state, and that name is bromine. So if a question comes, name a non-metal which is present in the liquid state, then your answer should be bromine, and the symbol of bromine is Br. So it is the only non-metal which is present in the liquid state. So we can write only only non-metal. Only non-metal which is present in the liquid state is bromine, and if the question is name two elements which are present in the liquid state, then the answer should be mercury, which is a metal, and bromine, which is a non-metal. And if we have to talk about the non-metals which are present in the gaseous state, then we have many non-metals which are present in the gaseous state. So you must also know the examples like oxygen, nitrogen, hydrogen, etc. So I hope students the physical state of non-metals is clear to you. Next, what about the hardness of non-metals? Are they hard or they are soft? So what about the hardness? They are opposite to the metals. As metals are generally hard, these non-metals are generally soft. So these are generally soft. What is the reason behind their soft nature? So if we have to discuss the reason for this, then the reason is less rigid or less compact packing of their atoms. So the reason is less rigid packing of atoms. Less rigid packing of the atoms in the non-metals is the reason behind their being soft. Next, we have an exception to this also. Let us study the exception. The bond which is formed between the two non-metals, that bond is known as a covalent bond. And when we have to talk the exception to the softness of the non-metals, then a very good example is diamond. Diamond is an allotrope of carbon. What are allotropes? Allotropes are the different forms of the same element which have same chemical properties but different physical properties. So this diamond is one of the allotrope of carbon. Other allotropes of carbon are like coke, charcoal, sugar, black. Then we have graphite also. So this is one of the allotropic form of carbon, and carbon is a non-metal. When we have to discuss the exception to the hardness, then we have diamond because it is the hardest natural substance known and it is a non-metal. It is the hardest natural substance. Hardest natural substance. So if any time question comes, name the hardest natural substance, then your answer should be diamond. The reason behind the exception of diamond is that it has a three-dimensional structure and it involves extensive covalent bonding, and because of extensive covalent bonding present in the atoms of the diamond, it is very hard. Now I think the two physical properties are clear too. Let us study some more physical properties of nonmetals. Now let us know about the melting points and boiling points of nonmetals. So third physical property, melting and boiling points. In comparison to metals, nonmetals have low melting and boiling points. So what we can write here, they have low melting and boiling points. Now what is the reason for their low melting and boiling points? Let us know the reason now. The reason for the low melting and boiling point is the less compact packing of the atoms in the nonmetals. So the reason is less compact packing of their atoms. So when we talk about the melting and boiling points of nonmetals, we say that they have low melting and boiling points, obviously in comparison to metals. But the reason for this is that they have less compact packing of their atoms, therefore they have low melting and boiling points. Next physical property. Now next physical property which we are going to study is conductivity. What about the conductivity of nonmetals? Are they good conductors of heat and electricity? No, they are bad conductors of heat and electricity. So I can write bad conductors of heat and electricity. As metals are good conductors of heat and electricity, when we talk of the non-metals, they are bad conductors of heat and electricity. Now, conductance of the electricity is because of the presence of free electrons. And why they are bad conductors of heat and electricity? Because of the absence of free electrons. So, the reason then becomes, reason we can write is absence of free electrons, and free electrons are responsible for the conduction of electricity. Now we have an exception here also, and the exception is an exception to the conduction of electricity of the non-metals is graphite. And what is graphite now? It is the allotropic form of carbon. One of the allotrope of carbon. As I discussed before, that allotropes are the different forms of the same element having same chemical properties but different physical properties. We have many allotropes of carbon like graphite, coke, charcoal, and here we have graphite. It is also one of the allotropic form of carbon. In graphite, we have freely held electrons, or we can say free electrons. Therefore, these free electrons are responsible for the conduction of electricity. Though graphite is a non-metal, it should be a bad conductor of electricity, but because of the presence of the free electrons in graphite, it is a good conductor of electricity. So, it becomes the exception here. Now, next physical property. What about ductility? Do non-metals show the property of ductility? No, non-metals are not ductile. So we can write non-metals are not ductile. Actually, they are brittle. Now what is this? We know that ductility is the property possessed by the metals by which can be stretched into long chains or wires, and as non-metals are non-ductile, they actually break when we try to stretch them. So that property is known as brittle. When we try to force them, they actually break, and that breaking property is known as that they are brittle. So when we talk of the ductility, non-metals are not ductile. Now next about malleability. Are they malleable or not? When we talk of malleability, this malleability is also a property possessed by metals only. So we can say non-metals are non-malleable. Non-metals are non-malleable. That means they cannot be beaten into thin sheets. So these are non-malleable. So obviously the reason is that we have never seen the thin sheets of non-metals. The non-metals are like sulfur, carbon. We never see the thin sheets of carbon, sulfur, phosphorus, etc. The reason is that they are non-malleable. So these two properties, ductility and malleability, these two properties are just possessed by the metals. So we do not actually talk of these properties in the non-metals. So this is one of the differentiating points between the metals and the non-metals. Now next physical property. Now students, next physical property which we are going to study is seventh physical property, and that is luster. As metals possess luster and non-metals are different from metals, so they do not possess luster. Do not possess luster. But we have exceptions to this also. Let us know about the exceptions. We have some non-metals which possess luster and are like graphite. We know that graphite is allotropic form of carbon. So carbon is a non-metal. So this graphite, one of the allotropic form of carbon, possess luster. Next non-metal which possess luster is iodine. So iodine also becomes an exception to luster of the non-metals. It also possesses luster. So I hope students these physical properties are clear to you. Next physical property is strength. Are they as strong as metals? No, they do not have that much strength as is possessed by the metals. So have less strength. Therefore, we do not see any strong substances made up of non-metals, so they have less strength. Now, next physical property we discuss about is sonority. We know that sonority is the property possessed by the metals by which they produce ringing sounds when they are struck hard, but non-metals are non-sonorous. So we can write non-metals are not sonorous. So non-metals are not sonorous. This is obviously because if something, a carbon made product falls on the ground, it never produces sound. Whereas the coins which are made up of metals, when they fall on the ground, we hear the sound. We have the lead pencils, and the lead is actually made up of one of the allotropic form of carbon, which is graphite. And obviously the pencil lead, when it falls on the ground, we never hear the sound. The reason is that the non-metals are non-sonorous. Next physical property is about their color. What colors do they possess? So let us know about the color of the non-metals. They are present in different colors. As metals are generally present in the grayish form, grayish color, these non-metals possess different colors. Let us know the colors of different non-metals. We have sulfur. The color of sulfur is yellow. Phosphorus is a non-metal. Phosphorus is also present in different allotropic forms, and its different allotropic forms possess color white, black, red. So these colors are of the different allotropic forms of phosphorus. Next we have chlorine. Chlorine is a yellowish green color gas. So what is the color of chlorine? It is a yellowish green color gas. Yellowish green color gas. What is the color of charcoal? Charcoal, or we can say we have graphite also. We can say we have charcoal, graphite. Now what is the color of charcoal and graphite? These are the allotropic forms of carbon. The color of charcoal, graphite is black. So here clearly we can see that non-metals are present in different colors. Sulfur in yellow color, chlorine in greenish yellow color. Then we have charcoal, graphite in black color, and phosphorus, whose allotropic forms are present in different colors: white, red, black, etc. So students, these were the physical properties of non-metals. I hope these physical properties are clear to you. Next we will study what are the chemical properties of non-metals.